Hi and welcome to my playhouse, and we're in the creepy basement. So I have a little bit of a fix that I want to do today. I have a product here. So let's see. This is a fiber optic microscope. It's this little thing down here. Come on out, one-handed. And this one is used to check the fiber optic and fiber optic cable, like these, very thin stuff. And yeah, you can look at the end of them and make sure that they are perfectly clean. And if they're not clean, you use a fiber optic cleaner. I've done multiple videos on that, so we're not going to go into that. I am going to brag a little bit. I did my first fiber optic split ever, splicing two cables together. You can see the yellow one and the green one here. I got to try out a machine, and I think I might be able to borrow one of those machines. He promised me that I could borrow one of his splicers, and so I could do some videos on showing that how I do it. I'm not a professional, naturally, as this one is my first ever one and I got to keep it. But this little thing, which this is actually mine. It's not mine, but it's mine at work. So this one is one that I keep safe. We have long figured out that if we have equipment that is everybody's responsibility, no one is responsible. So I have this one, and this is mine, and I'm responsible for that one, and therefore all the pieces are here always. So yeah, just a little thing. If people have their own stuff and put their name on it, well, they're more likely to look out for it. But these things has battery packs inside, like this one and that one, and they have a tendency to go bad. And this is not a cheap device. This is approximately 3,500 euros ish. They might have come down in price since we purchased this, but they're not cheap. And the battery packs aren't cheap either. So a battery pack like this is about $50, 50 euros ish. And everything it is just 3 AA batteries spot welded together in a specific way. And it's not even very good. So I'm gonna check if these batteries are worth saving, or if we should just build some new ones. So yeah, that's the simplicity of this video. So I'm gonna get cutters, and I'm gonna very carefully cut this open, get the cells out, and check them. So as any other doctor, scalpel, and I am hoping to be able to use this green plastic again. So I want to cut it somewhere where I can reuse it. So I am trying to figure out where that might be. I think if we cut it right here, it's going to be very easy to put that back together, and I can tape it there. Okay, maybe it's not that easy. There we are. Seems like we have it. So we need to get it out, and this is where it might all break. Okay, seems good. Okay, so that's how they made it, and they have just kind of super glued it in place. Okay, but we have 3 cells here, and these are they are GP, and funny enough, this reusable battery that I was showing in the start is the same brand. So I would be able to take 3 of these and make one of these. Just the ends would be a little bit different. I think we could, if these are totally dead, I think I can do it with those. So, and these are of course spot welded together with some thin stuff. So there is no magical things there. So, okay. Okay, I actually forgot to measure the voltage and show you the voltage before we started dissecting this. So, yeah, these are not lithium ion batteries. These are nickel metal something, nickel metal hydride. I don't know, batteries, but they are a bit low. So 3 batteries are at 2.2 volts. That tells me that they're probably not awful. Probably just undercharged. So I want to check each of them and see if they are in balance. Can you see the number here? I think we'll move this around a little bit. Get this to higher ground. And then measure this. Let's see what we have. We have 0.8, which is low. We have 0.75, which is low. And then we have 6.63, which is low. So, do they work as is, or do we have to do something? So these batteries are not entirely normal AA batteries. They're like slow batteries. They have a big capacity, but you're not meant to charge them very fast, whereas these can be charged a lot faster than these. Actually the same chemistry, I see. They might not be that weird then. So I think we should try and charge this first and see what we get out of that. So how do I charge these? We've got to figure out something brilliant, I'm sure. Okay, I found some magnets that I've been able to connect to the leads here. Just, this thing is magnetic. It's really, I don't think it should be, but it is. Might have been too cheap. So that's the positive and that's the negative. So we have our trusty power supply over here, which is, funny enough, set to just about the right voltage. So yeah, these batteries, I know that for a fact that the charger for this device, because I have it in the box, gives out 5 volts. So I think we should be able to charge these with about 5 volts. Because they're nickel metal hydride, they don't do the same limitations as the 5 volts. And then we can connect this, and then we will limit the power. There is actually not taking in too much of, but we could turn it. Let's see, it says, what did it say? It said 220 milliamp hours, and that's just about what it's taking in, and it's good. So I've actually, I don't know, that's total random that it's at the right place. So maybe they just need a bit of a charge. Okay, I was expecting that I would have to do a lot more. I was expecting a dead cell in middle of it or something else, a totally dead cell and 2 good cells. I probably didn't have to take the wrapping off of this. So I have connected the other one as well, just because if it really takes 16 hours to charge this up, well, I'm ready for my retirement then. So right now I have added some more current here, so now we are charging with 220 amp hours on each of them. It's just 1.84 watts, so it's still gonna take forever, or I might get out of here before retirement. Okay, they have been charging for an hour or so, so let's see, we are at 1.4 volts on that one. see. Okay, they're doing pretty good charging up. So maybe that's all I need. You are allowed a portion of hopeful thinking. Okay, it's much later in the day. It's about bedtime, and I was just checking up on this before I'm gonna go off to bed. Nothing has happened. It has been charging with this all day. It has, well, 4.4 volts. And still taking in like 220-ish milliamps per battery and about 1.8 watts. I would really expect it to go down. This has been running for, well, I would believe more than 10 hours by now, so they just keep taking a chance, these batteries. Maybe that's why they die. They don't stop charging. I don't know. I hate this chemistry. Yeah, I'm so happy that lithium batteries are the new thing, because this stuff just isn't as great. So I disconnected one of them, and it's very nicely fully charged. So this is a 3.6 volt battery, and it's right now sitting at 4 point something. So it's very good. Good morning. It's the next morning. So let's see. These batteries has dropped a bit. So this one is at 4.14, and this one is at 4.17. So are the cells, are they balanced? Oops. 1.389, 1.388, 1.392. That is very well within what you should expect and be happy with. So I don't know. Is there any power in these? So let's try and put them in the microscope. I'm not thrilled about this, because this is a rather expensive thing, so I really hope I'm not gonna mess anything up. So first we're gonna take my battery out, and I'm just gonna mark it with my name. Morten Hjort, MH. So I know this is my battery. So okay, there is some charging thing here. So very good quality, I must admit. So let's try and pop this battery in. Well, let's try and pop this one in. That's a funny one. And there is nothing there that can short it out, which is positive. Okay, it goes in that way. There. Power it on. Battery is full. Looks good. And it's a microscope. We could just see that. We need to use some power from it anyway, so I'll just put it there and I'll go get a cable. Okay, so here is one of those fiber optic cables. We use a lot of these at work, and this is an LC connector. So a cable like this with an LC connector in each end is called an LC-LC cable. It's very sophisticated, I'm aware. So let's try and test this. So naturally I would put the back on this, but for now let's just not do that. So the issue with these batteries was that they wouldn't last very long, and I'm a bit impatient, so we're not going to be doing a well, this video is not going to be doing that thorough test. So you test the cable by putting it in here, and you see on the screen here this cable looks very dodgy. I think there's a lot of imperfections in this one. I think that might be why I have it as a test cable, but you can clearly see we can do an auto. It will check the cable. This should really fail. Yeah, it will fail. So we have the cleaning thing, which is over here, that one, which is a little thing. I don't think I can show you that, but in here there's the tiniest little metal thing. I can probably zoom. Oh, we have a microscope right there. Maybe we can make that happen. We have a little thing here with a pin, and there is a bit of string that goes over that pin. So when you click it, there's a little bit of cloth that moves around that little pin and cleans the head or the end of the fiber optic cable. So if we zoom out and get rid of that again, you take the fiber optic cable, you put this plastic thing back on there. This is just to make the alignment correct, and then you put these into the end of this and you click it. And these pens are very expensive. It's a very niche thing, so for testing purposes and just playing with this, I'm just gonna do it once. And then when you've done it, you make sure not to touch this, because you will totally mess that up. So it looked like that. So let's get that again. See if we got any improvement. And you can see it has already, I'll just test it again here. It has improved it enough, so this one is okay. Let's check the other one. And that one is also good. There's the whole white thing around here. That's the end of the fiber optic cable. And then there's the black dot in the middle, and that's where the light actually goes through. And we can see that. Oh. If we take I have a laser over here. This is a laser light, and it has a thingy on it that fits on an LC connector, and when I turn it on, it very clearly shows that the battery is completely dead. So yeah, this is a Chinese thing, and at some point I have probably left it and it has used all the battery. So I'm gonna change the battery and I'll be right back. Okay, laser light has been restored. Renewed batteries, so we can now take the laser here, and I'll just get this. My pride and joy is getting in the way over here. So my little first ever. I don't have anything, so that I could check this cable, which is a bit of a shame. That would have been fun. Now we can take the laser and we can connect it to one of the leads here, or it's not a lead, it's a there. So now we're pumping out the laser and it comes out the other end of the cable here. I think you can see that, and then we can see it with the microscope. Magnets. We can ask the microscope to see. It's over here. So now we see a lot of light coming out of the microscope, and that's because it just sees the laser. You can still determine if there is something really messing up the cable even when the laser is coming through. If this was some usable equipment in the other end, The light is normally not that bright as the laser here, but yeah, it is possible to still test the cable. But it seems like this is it's not doing too badly. It still holds battery. So I think that battery is, let's power it off and see what the battery voltage is at. If they have dropped a lot. Okay, it was 4 point. It was 4 point. I forget. It has dropped some, but it's still way over 4 volts. And each of these cells are only like 1.2 volts. So combined, they should be like 3.6 volts, and they are considerably over 3.6 volts here. So I don't think they're that bad. So I think maybe the batteries they have just not been charged up well enough. And every time they've charged like 10 minutes and 20 minutes, and then the device has been used, which is pretty normal, because you get the device out of its packaging and then you need it, and then you do what you need to do, and then you don't charge it up. So I think what is needed for these is just leave it in the charger overnight and use it until it complains about battery. It's not uncommon. So I don't think I'm gonna do anything more with these batteries. I'm just gonna decide that they're actually not that bad. They're not bad enough to do a whole lot. And another thing that I've realized is that they are normal AA batteries, so making a replacement pack is definitely doable. So that's a nice fix. I just need a little bit of clear tape and we're good to go. Okay, well now I can clearly see that I've messed with this package. It got some fireproof tape, Kevlar tape-ish. So now we can put this back in, and we should just check if it still fits. They don't go in very easily. That's a tight fit, which is probably both good and bad. So looks good. And it powers right back up. Okay. I think I'm well happy with that. So these are the batteries that I've messed with. So this one is the one that came out of my device, and that measures 3.7, and I know that mine isn't fully charged, so we can put that back in, and we should see what percentage of charge it thinks that it's at that level. Okay, so you can actually see the battery is not at full. There is the smallest little sliver missing up there. So yeah, I have a tendency to not being able to throw anything away. I think I've mentioned that multiple times, and it just helped me because when I was messing with this device, I could see that I only had one screw in it. I thought, where has the other screw gone? I thought, if I have come across a screw, where would I have put it? I wouldn't have thrown it out because it didn't. Oh, we can actually see that it has dropped now, the voltage of the battery. We can turn it off. Where would I have put it? Well, I would have put it in the box with all the accessories to the microscope. So the microscope can be changed. You can replace the head of it if you need to measure other cables. So it has this little box. These are the different heads that I have for it. So you have this square one. I think this is for SC connectors, and then there are some for some other connections. I never use these, so yeah, I don't think I have one that can that can test my own cable that I've made. But yeah, I have a little box. I also have a lot of these end things that goes on the end of the fiber optic cable. So let's just, we have cleaned this. So in real life scenario, I would take a couple of these end caps and I would put those on very carefully. Be careful not to touch the end of the, I fucked that up already. Put that on like that. Not touching the end, but sliding it on from the side. Like something like that. And then now I can't dirty up the cable. So I have a lot of those if I should ever need to do that somewhere. So I have those along. Very often when you're doing this sort of work, it's when something isn't working. So I have a whole collection of, this one says mistænksom, translated to English that is doubtful. This one just says bad, and this one has a minus sign. I should really be more do it the same way, and bad, bad, bad. So yeah, normally I keep them, and I have this SFP tester. At the moment, it's actually my own tester, but it's laying at work at the moment. So when I get back, I usually, and remember it, I usually test some of the SFPs to make sure if they're actually bad or if it just randomly became better when I was messing with it. And sometimes that happens too. And sometimes the SFP is just doubtful. So yeah, I think these two batteries are perfectly fine. So this wasn't much of a video, more or less it was me charging up two batteries. Expensive packs though, because these packs are 50 euros a piece and they're only available from the company. But as I thought they might hide some more difficulties, bad cells or something, I thought it would be worth a video. It kind of wasn't, so I've been wasting your time, so I'm gonna wrap it up before I waste too much of your time. But it's not a waste of time to check out stuff that has broken, see if you can fix it yourself. Here's $100 that I don't need to, well, I'm gonna give these are not mine, I'm gonna give them back to the guy that has a couple of these microscopes and has had issues with the batteries. So he's gonna get them back. I could just show you the charger though. This is the charger for the device, and it's like 5 volt 2 amps, and it's one of those Chinesium ones where you are doubtful that if they have remembered to put anything in it. It's one of those smart ones where you can replace the front of it and put in other countries' sockets instead. So yeah, I charge mine up regularly before it runs dry. And I think that might be the issue, that they have run dry and they have come down so low that they refuse to charge back up again. So I'm gonna leave the guy with that. And thank you very much for watching my videos. Do subscribe to my channel so you can see me again, and have a really nice day. Bye bye.